Today we shall discuss about the limit at infinity. When x tends to infinite, what do you mean by that? When x values are increasing very large every time as x become bigger, we say x is tending to infinity. And if it becomes negative, then we say x tends to minus infinity. Infinity means very large number which you cannot define. What we are going to do is, when x is tending to infinity, what happens to the value of the function? That's what we are going to discuss in this particular case. One thing you must remember, infinity minus infinity cannot be done. You cannot subtract it to infinity. Too large number minus too large number, it is not zero. Same way, infinity, addition infinity is infinity. Infinity multiplied with infinity is infinity. Again, infinity divided by infinity cannot be done. So you should remember, subtraction of two infinite terms is not possible. Division of two infinite term is not possible. So if you add two infinite term, you'll get infinity. Two infinite term, if you multiply, you'll get infinity in case of limits. Okay, now let's have a look at the function's value. When x is tending to infinity, how much will be 1 by x? When x is tending to infinity, how much will be x square? Limit x tending to infinity, how much will be x cube, etc. Here, limit x tending to infinity, 1 by x square. So when x is tending to infinity, that means denominator becoming very large. We know that 1 by 10 is 0.1, 1 by 100 is 0.01, 1 by 1000 is 0.001. So as we see that denominator numbers become bigger and bigger, the value of the number becomes smaller. So I can say this is tending to 0. 0.001 is very small number. So when x tends to infinity, 1 by x will tend to 0. 1 by x square also will tend to 0. So my conclusion is, if n is a number greater than 0, limit x tending to infinity, x raised to minus n will be 0. Let's have a look at this. If a large number, if you square, you'll get still a large number. So this will be infinity. So my conclusion is, limit x tending to infinity, x to the power n will be infinity if n is a positive number. So if n is greater than 0, positive number, if the x raised to n will be infinity. If n is negative number, that means if the x is in denominator, it becomes 0. Since operation with infinity cannot be done, we always try to convert the function so that when x tends to infinity, we get the answer 0. Now let's have a look at this problem. Limit x tending to infinity, 4x square plus 3x plus 1 divided by 2x square plus x plus 1. You can see that the degree of the numerator and degree of the denominator are equal. So in such case, I will convert everything to 1 by x. So what you need to keep it in mind is, limit x tending to infinity, 1 upon x raised to n will be 0. Limit x tending to infinity, x to the power n will be infinity. So I cannot use directly the substitution method in this problem, because I'll end up in infinity plus infinity divided by infinity, which you cannot operate. So what I will do is, I will divide the numerator and denominator by the highest power. So 4x square plus 3x plus 1 divided by x square. Again 2x square plus x plus 1 divided by x square. So divided the numerator and denominator by x square. That is equal to limit x tending to infinity. When I 4x square upon x square, I can write it as 4. 3x square upon x square, 3 by x. 1 upon x square divided by 2x square divided by x square, x upon x square, 1 upon x square. Now we have seen these terms are nothing but 1 upon x raised to n form. So this will be 0, this will be 0, this will be 0, this will be 0. So I can write my answer as 4 plus 0 divided by 2 plus 0 plus 0. And my answer became 4 by 2 and the answer is 2. So when x is tending to infinity, the value of this limit would be 2. This is how we can calculate. Now let's have a look at another case. Imagine I have limit x tending to infinity, 4x plus 3 divided by 2x square plus 4x plus 1. Now what have we noticed here is the denominator's degree is greater than the numerator's degree. So what will happen in that case? This will become limit extending to infinity. Because denominator is much larger than the numerator, this will tend to, denominator became larger and numerator is smaller, so your answer will be 0. If the degree of the denominator is greater, the denominator become very large, hence answer will become 0. If the degree of the numerator is greater and denominator degree is lesser, the answer will be infinity. This is what you have to remember. You have to compare the numerator and denominator. Degree equal, divide by the highest power, divide by the highest power, divide the numerator and denominator by the highest power. Then what will be your answer? Your answer will be the coefficient of the highest power divided by the coefficient of the highest power. This shortcut you can apply. If the degree of denominator is more, the denominator becomes very large, hence answer becomes 0. If the degree of the numerator is higher, the numerator becomes very large, hence answer will be infinity. These are the 3 points to remember. So conclusion, if the degree is equal, coefficient of the highest power divided by the coefficient of highest power will be your answer. Denominator degree is greater, answer will be 0. Numerator degree will be greater, answer will be infinity. At this problem, here when x is tending to infinity, if I substitute infinity minus infinity, which cannot be calculated, so what I will do is, in such problem, we'll have to rationalize. So I'm going to multiply numerator and denominator by the conjugate. So root of x square plus 2x minus x into root of x square plus 2x plus x divided by root of x square plus 2x plus x. So what I have done, I multiplied the numerator and denominator by the same quantity, and this quantity is the conjugate of this. Because this is a minus b, this will be a plus b, so that I can remove the square root in the numerator. So limit extending to infinity, a minus b into a plus b will become x square plus 2x root square minus b square will be x square divided by root of x square plus 2x plus x. Now this square root and this square will go away. When again x square and x square will get cancelled. So limit extending to infinity, 2x upon root of x square plus 2x plus x. Now this has become similar to the previous problem. What is the degree of x here? 1. What is the degree of x square here? That is also 1. Degree of x here? 1. The numerator and degree are of degree 1. Numerator and denominator are of degree 1. So what I should do? I told you, whenever x is tending to infinity, divide numerator and denominator by the highest power. Here, instead of dividing, I'll make a small change. Now, I'll take the highest power x here, I'll take x common. So limit x tending to infinity, 2x upon root of x taken x square into 1 plus 2 by x plus x. That became limit x tending to infinity, 2x upon x into root 1 plus 2 by x plus 1. This x and this x will get cancelled because root of x square is x. That gives you limit, now I'll put the limit here, this is 0, so 2 by root of 1 plus 1, that is 2 by 2, which will give you answer 1. Now you can do this problem directly also. What is the coefficient of highest power here? 2. So the coefficient of highest power is 2. Coefficient of highest power in the denominator, root of x square is x, its coefficient is 1. This is not highest power, this is highest power, so its coefficient is 1. So 2 by 2, answer is 1. This is a short method to do it, but just I showed you how it works. So next time onwards, when you have the same degree, just collect all the highest powers coefficient and put it, you will directly get the answer. You don't have to do this procedure. X is tending to minus infinity this time. Whenever x is tending to minus infinity, what you should do is put y as minus x. So as x is tending to infinity, minus infinity, y will tend to plus infinity. Plus infinity is easy for us to calculate because of the square root. So I can write instead of this, limit y tends to infinity, root of, instead of x, I am going to replace minus y, square it, so it will become y square. Instead of x, I will replace minus y, and instead of x, I will replace minus y. So our new function is like this. Now, like the previous problem, we will rationalize it and then we'll apply the highest power method. So limit y tends to infinity, rationalizing it, root of y square minus 8y minus y into root of y square minus 8y plus y divided by root of y square minus 8y plus y. Now this became, when you calculate this limit y tends to infinity, so y square minus 8y square root a minus b into a plus b is a square root went away, minus y square divided by root of y square minus 8y plus y. Now y square and y square got cancelled. Now I am not going to do the whole problem. I am going to go for the coefficient of the highest power. What is the highest degree here? Y's degree is 1. What is the y's degree here? Root of y square. Root of y square is nothing but y. So here also degree 1. Here also degree 1. Numerator degree and denominator degree are equal. Whenever numerator degree and denominator degree are equal, the coefficient of the highest power. What is the coefficient of the highest power? Minus 8. Divided by coefficient of the highest power 1. Root of y square is y. So coefficient 1. Coefficient of 1. So minus 8 upon 2. So answer is minus 4. So you don't have to divide numerator and denominator by the highest power. You can use this shortcut. Whenever degrees are equal, when the degree of the numerator and denominator are equal, take the coefficients of the highest power. Here it is minus 8. Here there is a y, its coefficient is 1. Here there is another y, whose coefficient is 1. Plus sign is between. So you get minus 8 upon 2 and answer is minus 4. This problem looks a little complicated, but we can do it very simple. Mentally we can calculate it. You can see everywhere the power is 10. Here also power is 10. So the highest power of x, here is x raised to 10. Here also x raised to 10. Here also x raised to 10. Here also x raised to 10. So everywhere the degree of this polynomial will be, power will be 10. And the here degree of the polynomial will be 10. Both the degrees are equal. Hence the limit will be coefficient of the highest power divided by the coefficient of the highest power. So what are the coefficient of the highest power? So I will collect coefficient of 10 divided by the coefficient of 10 x to the power 10. Coefficient of x to the power 10 divided by coefficient of x to the power 10 is my coefficient of x raised to 10, 1, 1, 1, etc. How many times? First, second, third, 2012. So I'll write 1 plus 1 plus 1 plus how many times? 2012 times. Repeated. Divided by coefficient of x raised to 10, here is only 1. So your answer became, it is added how many times? 2012. So 2012 divided by 1. So answer is 2012. Here is a logical problem. The limit of this function is 2. What should be the value of a and b? Find what is a and what is b. You know that x tends to infinity, a polynomial divided by polynomial can have a proper answer only when the degree of the numerator and degree of the denominator are equal. So what I'll do is, first I will take the LCM, x plus 1. So I'll get x square minus 1 plus ax into x plus 1 plus b into x plus 1. This one's limit should be 2. That is limit extending to infinity. How many x square term? 1 here, 1 here. So 1 plus a into x square. X terms are ax into 1 and bx. So a plus b into x. Constant terms are minus 1, then b. Divided by x plus 1 should be 2. Here the degree is 1. So the numerator degree also should be 1. Otherwise limit will not exist. Either limit will be 0. Suppose degree of denominator is greater, my answer would have been infinite, 0. And if the numerator of degree is greater, my answer would have been infinity. Now since the answer is 2, they both should be of the same degree, which means 1 plus a should be 0. So if 1 plus a is 0, that means a's value should be minus 1. Once a's value become minus 1, this limit will reduce to, this will become 0, this is minus 1. So minus 1 plus b into x minus 1 plus b divided by x plus 1 should be 2. Now they both are of the same degree. And you know that when x is tending to infinity, the answer for this limit will be coefficient of the highest power minus 1 plus b, coefficient of the highest power 1, and that should be equal to 2. So b should be equal to 3. So a's value should be minus 1 and b's value should be 3. Let's discuss limit x tending to infinity a raised to x. When a is a number more than 1, this will tend to infinity. How? Let's say 2 raised to infinity will be infinity. 2.1 raised to infinity will be infinity. 1.5 raised to infinity, that is also will be infinity. So if the number is basis a number more than 1, your answer would be infinity. If the base is exactly 1, if base is exactly 1, it will be 1 raised to a large number, which will be 1. If the base is between 0 and 1, that means like 1 by 2. 1 by 2 raised to infinity. That means 1 by 2 raised to infinity, which means 1 by infinity. 1 upon a large number is 0, hence this will be 0. Now, if a become negative, if a is less than 0, it will oscillate because it depends on negative 2 raised to infinity, positive 2 raised to infinity. That is, suppose you have a square here, this will turn to 4 raised to infinity. If it is a minus this number, x became a negative number, then it will become a negative number. So it will oscillates. Therefore, it does not define. Or you cannot, it does not exist, it's better. Does not exist. That means you cannot find the limit. So if I ask you, limit x tending to infinity minus 2 raised to x, your answer will be, does not exist. You cannot calculate. If the base is a negative number, the limit does not exist. If the base is 1, the answer will be 1. If base is a number between 0 and 1, then the limit would be 0. So please note this. Now let me ask you to calculate this. Limit x tends to infinity, let's say 4 raised to x plus 5 raised to x, the whole raised to 1 by x. I want to calculate 4 raised to x plus 5 raised to x raised to 1 by x. Remember, a perfect value will arise only if the number is greater than 1, it will be infinity. If the number is 0 to 1, then only it will be 0. So what I'll do is, I will take a 5 raised to x common. 5 raised to x common. So that this becomes 4 by 5 raised to x plus 1. Now 5 raised to x raised to 1 by x, that will become 5, and this become 4 by 5 raised to x plus 1 raised to 1 by x. Now what I can say here, this became 5, 4 by 5 is a number between 0 and 1, therefore this will become 0, this will become 1, and this will become infinity. So your answer will be 5. Because 1 to the power infinity is 1. So this will become 5. So just look at this. Why did I take 5 raised to x as common? Why not take 4 raised to x as common? If I had taken 4 raised to x as common, I would have got like this. 1 plus 5 by 4 raised to x. I would have got this way. Now 5 by 4 is a number more than 1. And this would turn to infinity and I would not be able to calculate it. So that's why, while taking the number common, the number that you get here should be a number between 0 and 1. Then only its limit can be replaced by 0. Then only this calculation can be done. So remember, the bigger number is taken common. Out of 4 and 5, 5 is bigger. Bigger number is taken common and calculated the limit. Similar to the previous problem, you can see 5 raised to n, 6 raised to n, n is tending to infinity here. So again, I need to have a number between 0 and 1. Then only a raised to n will tend to 0 when n tends to infinity. When n tends to infinity, a raised to n will tend to 0 if only if a lies between 0 and 1. So 6 by 5 is more than 1. 5 by 6 is less than 1. So what I should do, I will take 6 raised to n common. So 5 raised to n upon 6 raised to n plus 1 divided by 6 raised to n, 5 raised to n divided by 6 raised to n minus 1. so that this 6 raised to n and 6 raised to n will get cancelled. So limit n tends to infinity, I can write 5 by 6 the whole raised to n plus 1 divided by 5 by 6 raised to n minus 1. Now a is a number between less than 1, and when a power becomes infinity, this will tend to 0. So your answer became 0 plus 1 upon 0 minus 1. So minus 1 is my final answer. Let's have a look at this problem. This is a continuation of sequence and series chapter when we did summation of series. So numerator is a series. So we'll need to use summation of series. So numerator's rth term, first term is 1 into n, second term 2 into n minus 1, third term 3 into n minus 2. So term number is 1, it is n. Term number 2, 1 is subtracted. Term number 3, 2 is subtracted. Term number rth term, r into n minus r, 2 it is 1, so r minus 1. I can write this way. So the numerator is nothing but rth term of the numerator is r into n minus r minus 1, which can be written as r into n minus r plus 1. Now the numerator can be written as sigma r is equal to 1 to n. When r is 1, I get 1, r is 1 to n, r into n minus r plus 1. For convenience, I will expand this as n and 1 I'll take together. So n plus 1 into r minus sigma r square. So n plus 1 is a constant because what is the variable here? R is varying. Sigma r minus sigma r square. Now sigma r, sum of the natural number, sum of the square of the natural number. What is the formula for sum of the natural number? N into n plus 1 upon 2. Sum of the squares of the natural number, n into n plus 1 into 2n plus 1 upon 6. So I can write the numerator in this format. N into n plus 1 the whole square. So this I can write as limit n tends to infinity. First one, n into n plus 1 the whole square divided by 2 minus n into n plus 1 into 2n plus 1 upon 6 divided by n cube. Now things you can just do it mentally. Degree of the numerator, this n square into n, n cube. 2n into n into n. The degree become n cube. Degree n cube. So degree of the numerator is n cube, degree of the denominator is n cube. If the degrees are equal, the coefficient of the highest power divided by the coefficient of the highest power. So let's have a look at the coefficient. So coefficient of n cube here will be 1 by 2. Because when you expand this, n square plus 2n plus 1 into n, so n cube will be there, denominator 2 is there, so 1 by 2 will be the coefficient. When you expand this and this, that is 2n cube divided by 6, so 2 by 6, and here it will be 1. So your answer is 1 by 2 minus 1 by 3. So answer is 1 by 6. So your